Okay, the next thing that we're going to cover is how to make a histogram from a frequency distribution. Now, histograms in Triola's book are covered in section 2.3, and so that's the section that we're going to be covering. So the first thing I'd like to talk about in section 2.3 is what a histogram is very similar to. And a histogram is very similar to a bar chart or a bar graph. And like a vertical bar graph, it has bars that are separated out by groupings, categories. The bars are of equal widths, and their heights tell you how much quantity is in each one of the categories. However, in a histogram, unlike the bar chart, we have no gaps between the bars. The horizontal axis is going to reflect not just any old category, but the classes that we have set up in a frequency distribution. The edges of the bars are going to touch one another, meaning that there's no gaps between them, and they're going to have bar edges at the class boundaries. This way we set up in such a way that our bars are representations of the mutually exclusive classes, but they then touch and don't have the gaps, because the gaps are going to show us a different visual picture than if we did not show gaps in the first place. The vertical axis is going to reflect our frequencies or our counts, or a relative frequency. Now, Triola, as in many textbooks, shows relative frequency histograms, and I'm more apt to show just a frequency histogram. Also, just kind of as a little side note, I like to label my bar heights right on top of the bars so I make it easy for my reader to read. This is just a nicety in my case. So let's go back and let's take a look at the frequency distribution that we created for the purse snatcher data, and we're going to create a histogram from that. So going back here, remember these were the relative frequency distributions and the cumulative frequency, and this was our frequency distribution for the purse snatchers. So we had classes 16 to 24, 25 to 33, 34 to 42, 43 to 51, and then remember in the next video after this, I showed you how to find the boundaries. And it's actually those boundaries that we're going to be using. The boundaries in this case are listed on the relative frequency histogram here in green. So we have 15.5 to 24.5, 24.5 to 33.5, 33.5 to 42.5, and 42.5 to 51.5. And our counts are 3, 4, 2, and 1. Now, if you're doing a relative frequency histogram, we would put in the decimals here instead of the actual counts. But as I said, I'm more fond of doing just a regular histogram, a frequency histogram rather than the relative frequency histogram. So I've set up here for our frequency histogram of purse snatchers, and notice I've labeled the entire graph. My vertical axis is going to represent my frequencies, and I put in 0 as where we're starting, and then 1, 2, 3, 4, and 5. And then my classes down here, each of these are separated out into equal lengths or equal widths, and I've started here at 15.5. And so my next one is going to go to 20. Let's see, what was it, 23.5 or 24.5? I can't remember. My memory's going. 24.5. So 24.5. It would be nice if we had these right next to one another when we were trying to create this relative frequency histogram, but unfortunately I do not. And so then remember that if I don't have those to look at, my class width was 9, so I can add 9 to this, and this will give me my next class boundary of 33.5, and then add 9 to that, and my next boundary of 42.5, and then my next boundary, of course, at 51.5. And those would be my boundaries. And now I'm going to go ahead and I'm going to put in bars of the height represented by the counts. So my first one was a height of 3. So I'm going to go ahead and I'm going to put in a height of 3 here. So right across here like this, and then this goes up like this so that I create my bar. And then my next one had a height of 4, so I'm going to put in my 4 right across here and create the bar out of that. And then my next one had a height of 2, a frequency of 2, so my bar is going to be 2 units high. And my last one has a height of 1, and so there's my height right there. And then, like I said before, I like to go ahead and put in my counts up here. So I like to put in a 3 here, and a 4 up here on top, and a 2 up here on top, and a 1 up here on top. Now, the next thing that we can do from a frequency histogram is we can start to see the shape of the data. So our shape of our data, we can talk about a frequency polygon. And from the frequency polygon, then we can start to really see the shape. So let's go ahead and talk about the midpoints here. And so the midpoint of this class, of course, is going to be right in the middle here. And these are actually 5 wide, so it's 2.5 across here, so right in there. And we could actually put in these midpoints, right, the class marks, by saying, okay, we have 24.5, and then we could add to that 15.5, and then we could divide that by 2. That's supposed to be a 4, by the way, and divide that by 2. And so we're going to get 40, and then divide this by 2. And that's going to be equal to, that's a 20, and that is our midpoint on the middle of this. So this point is at 20 here. And we could do that for each of these, or we could do another way, is 24.5, and we could subtract 15.5, and then we could divide that by 2, which gives us the distance from a lower class boundary to the upper class boundary, and or to the midpoint, or from the upper down to the midpoint. So 24.5 minus 15.5, which is going to be 9, and 9 divided by 2, and that's going to give us 4.5 there. And the 4.5 plus 15.5, which gives us 20. So those are the ways we could do it. Now, for the next one here, I don't even have to do anything more than just use the fact that from midpoint to midpoint is separated by class width. So this one must be at 29, and then class width is 9, so the midpoint here would be at 38. And then plus 9 again, and so the midpoint here would be at 47. And that would be one of the ways in which I could get all the midpoints. Now, once I have the midpoints, what I want to do is I want to create a graph that goes from here, and actually they start down here at 0, and it goes up to here, and then to here, and then down here, and then to here, and then down to here. And that is going to show you the frequency polygon. And the frequency polygon, what the purpose of showing one of those is it gives your eye the shape. So we come up here and we go along here and down here, and what we begin to see is we begin to see some of that skewed data. So let me just go ahead and draw that in here as just kind of the shape, and we see the skew here, the big bump on this side and trailing off to the right hand side. And that's what the frequency polygon is helpful. It helps us to see the distribution or the shape of the data. Remember, what we're looking at in both this chapter and the next is the idea of sieve dot, and remember that stood for center, variation, distribution, outliers, and time. And distribution is what we've just seen here with this polygon, and that's again the shape. Now, another thing that we might be able to see here is the center. The center of the data is kind of where the balancing point is. So where could we stick our finger on this number line and have it balanced out? So we've got a little bit more over here on this side and then we've got a little bit less over here on this side, and so it's going to be a little bit heavier over here, so we're going to have to balance our finger probably kind of somewhere in this point right here. And then another thing that we can talk about, and again that would be center, so you can see how this polygon or this histogram could show us how we have the center, because we could think of the balancing point. And for the balancing point, we could see a little bit about the center on that. Of course, it's not a fantastic way of seeing the center, but that's, again, what we might be able to see. Now, the other thing that we want to talk about a little bit and see how we can see this, start to see this, is with the variation. Now, variation, one of the major ways to measure variation is the deviation from the center of the data. How far does this data spread from its middle? And so one of the things that we can talk about is, well, where do we see most of the data? Well, if I had to ask you about a percentage that you would say, well, the majority of it, a lot of people will tell me, oh, well, they think that the majority would be, oh, I've heard anything from 85 to 95%. And as it turns out, with normal theory, what we're looking at is about 90%, 95%. And this is 2 standard deviations out. And so if we look at this curve and we say, okay, well, what would be encompass about 95% of the data? And we might say, okay, well, something about like this, right? And what we want to do is we want to kind of get the spread where it's equal on this side and equal on this side. And that is what we would encompass about 95% of the data. So what we're seeing is 2 standard deviations, so half here and half here. So with 1 standard deviation, it'd be somewhere in this area here, and that's what we're looking at for the variation. Now, outliers, I think we already talked about outliers just a tad when we discussed this data, but in case I didn't cover it, let's just talk really quickly about outliers. One of the things that we saw when we went through our cumulative distribution, and the relative frequency maybe a little bit as well, was that almost everything was encompassed by the time that we were up to the 2nd class, and very little were out here at the edges. And what we saw was that one 50-year-old was fairly old compared to everything else. However, all the other data was over here grouped, and then the 50 was way up here. And so that's an idea of an outlier, right? The 50-year-old was kind of old compared to the rest of the data. Now, that's not as apparent here in the histogram. However, what we're going to talk about in the next section with some other statistical graphs, and one of those being the stem and leaf and the other being a dot plot, is we are going to see a little bit more about seeing the outliers, and both the stem and leaf and the dot plots are fairly good about showing us outliers as well. So I'm going to leave that for our next little mini lecture.